मैं कह रहा हूँ कि सेक्युलर डायरेक्टिव ना आप स्टार्ट से बता दें एरिया से।
जी ठीक है, मैं बता देता हूँ. So in the previous lecture, we started off chapter 4, which was the basics of assembly programming. And if we have an overview of the last lecture, we were saying that the Cortex M architecture or ARM architecture supports the thumb 2 instruction set architecture. And thumb 2 instruction set architecture includes 16-bit thumb instruction as well as 32-bit ARM thumb 2 instructions. So it will have a better execution in terms of execution performance, and it will have a better code density as compared to the ARM. And the assembly language, why we use assembly language? Because it gives you a precise control, and the precise control will be given to you by some instruction sets. This was the main syntax of the assembly program. It will have an optional label. After the optional level, it will have an opcode, and opcode will have a few operands. It may have one operand, two operand, or maximum of 4 operands. And after the semicolon, you may add any optional command for your better understanding. This was the types of instructions. We will discuss the memory access instructions, the data processing instructions, and all these instructions in the next few chapters. So this was a whole hierarchical structure. This is one of the instructions about the syntax to write assembly instruction. You will add an opcode, which is a compulsory part. There is no label with this instruction, and these are its operands. Operands can be registers or it can be immediate values. So immediate value 10 has been given as an operand. So this 10 will be added in the second operand, which is R2, and the result will be stored in the first operand, which is the result carrying operand. So R1 will carry the result R2 plus 10. Similarly, if you will add only one operand at the second time, then the first operand will become the result holder as well as the input argument. So in this instruction, R1 will be added by 6, and the result will be updated in R1 again. Similarly, in this way, R4 is added by R2 content, and the result is stored in R4. There was a move instruction. Move instruction is just an assignment operator, and that assignment operator will assign this value in R2. Similarly, it will assign the ASCII value of A inside R4. It will copy the content of R3 inside R7. So this was the move instruction. In LDR instruction, LDR called the load instruction. So it will load the data contents from memory to the registers. It will have two different syntaxes. In the first syntax, if you will put R2 and R1 within a curly bracket or square brackets, then it means it will be fetching the data at the location which is pointed to by R1. So R1 is pointing to some memory location. The processor will go to that memory location. It will fetch the data from there, and it will load the value in the R2. So R2 will fetch the data that is pointing from the memory that is pointed to by R1. Similarly, in the second syntax, if it will have a number or a variable with equality sign, that number will be loaded inside R0. So it's just an extension of move instruction. And the store instruction was the one in which R4 is the data stored in R4 will be loaded at the memory location which is pointed to by R3. So at the memory location at which R3 is pointing at, it will contain now the value which is in R4. And the CBC was a compare by zero instruction. So we discussed this whole code and we debug it on Peel as well. But in the main assembly program, it will have a few assembly instructions, but it will have a few more things in it. And those few more things are the assembly directives, and it may require the macro directives as well. Now, what are those assembly directives? These are the few assembly directives. The first assembly directive and the very famous assembly directive is now area directive is the one. It will behave just like the curly brackets in your C code. If you understand the syntax of a C, then the segment of segment you will declare it as an area. After declaring it, you will add
सर आपकी
optional
आवाज क्लियर
attributes.
नहीं आ रही
You will add its name, and after adding its name, you will the code within that. आवाज
सर आपकी आवाज बहुत खराब आ रही है, नहीं आ रही है आपके पास.
इसमें क्लियर नहीं आ रही आवाज आ रही डिफाइन खराब आवाज हल्की
सर बहुत ज्यादा ब्रेक करी है
आवाज डिम आ रही है या आवाज नॉइज जी
सर ऐसे लग रहा है जैसे हम कोई डब स्टेप
लेट मी
म्यूजिक
चेक
सुन रहे हैं।
सर पियानो मिक्स हो रहा है।
ओके आप क्लियर है
Yes, sir.
जी सर
चलिए फाइनली So, कहाँ पर थे हम लोग? We were discussing the assembler directives, and the first and very famous assembler directive is the area directive. Area directive will behave just like the curly brackets in your C code. The size directives are used to declare the data inside your code. The first size directive is a space directive. Space directive is used to reserve some space for an array. So if you will write something like a variable name, after that you will write the space word and then you will define the memory. For example, 8 bytes, 16 bytes, 24 bytes. Then the processor or the compiler or assembler will reserve that much number of bytes with that variable. So you can define an array of any particular size using the keyword space. If you want to define a single variable, then that variable will be declared as either DCB, define constant byte. By writing this keyword, you may define a variable which has a capacity of 8 bits. DCW has a capacity to define 16-bit variable or half-word variable. And DCD is used to declare a variable of size 32 bits. So it's a define constant byte, define constant half-word, define constant data. Equalize symbol is just like the hash defined in your C code. So it will have a macro defined with a constant value, and it will copy paste that value in your code and will not occupy any memory. Entry is the entry point to the area, and end is the end line of the area or the end of the code. So it will be written at the end of either an area or it will be written at the end of your source file. So just like the end of a curly bracket, it will be declared as end. Now there can be a few global type of assembler directives as well. So these are called the macro directives. A global or export. Global is a keyword. If you will once again recall your C language, in C language there were two different type of variables. The first type of variables were the global variables, which are accessible throughout your program. And a few of them were the local variables. Local variables were defined within a vicinity of a single function. So if you want to declare a label which is applicable only to a certain or a single area, then you will define it as a simple label. But if you want to declare it as a global label, and if you want to call it in some other file or in some other area as well, then you will write an export word with it. So by writing export word with it, you can declare you can declare a label which is accessible in any area of your program. If you will give me a second, I will initiate the key. G, is the screen visible?
Yes, sir.
Okay. Now, if you have understood a few of the assembler directives, you can see those assembler directives over here as well. This is the assembler directive thumb. Thumb, by writing thumb at top of your program, it is asking the assembler that I am going to write the instruction in thumb mode. So in thumb mode, it includes thumb as well as thumb 2. So the assembler will either decode or encode those instructions as 16-bit, or either it will encode it as 32-bit. So thumb is a basically directive, and each directive will be written after a tab space. If you will declare it as without any tab space, then this word will be declared as a label. So thumb cannot be a label. So if you want to write an assembler directive, it will always be mentioned after a one tab space. Now the stack size. Stack size is basically a label. And this stack size has been equalized to 100 bytes, 100 hexa numbers, or if you are in decimal notation, then you can write it as 256 bytes. So this stack size is basically an equalizer or a hash defined keyword, and its value is 100. Whenever I will write wherever in the code I will write stack size, it will be pasted by a value 100. Now area. Area is a start of curly bracket. In this area, I am going to define my stack. So in this area, this is the optional name of the area. In this particular area, I am going to define my stack. No initializer. These are the attributes of the area. The attributes will be shown in a little while. This is a label, my stack mem. In my stack mem, we are reserving a space of equal to stack size. Stack size is 256 bytes. So we have declared a stack of size 256 bytes, and it has been initialized to 0. Whenever we will declare some memory with some storage capacity, then it will be initialized to 0. So space always initialize your memory by 0.
Excuse me, sir.
जी
सर स्पेस और एरिया में क्या फर्क है?
एरिया तो आपका कीवर्ड है ना, वो आपकी कोड सेगमेंट को डिफाइन कर रहा है कि यहाँ से आपका सेगमेंट शुरू हो रहा है एक नए कोड का. तो एरिया को आप यूं समझिए, एरिया आपकी कर्ली ब्रैकेट है, स्टार्ट ऑफ कर्ली ब्रैकेट है ऑफ योर सी कोड.
ओके सर.
And space is a keyword that is used to declare some space or or used to declare some variable or an array in general.
एक्सक्यूज मी सर.
जी
सर ये जो सिंटैक्स है ये एरिया का, इसमें लिखा हुआ है कि सेक्शन नेम भी आता है, तो वो ऑप्शनल होता है?
हाँ जी, वो ऑप्शनल है. ऑप्शनल नहीं है, आपका सेक्शन नेम रखना पड़ता है आपको, ये कंपलसरी है, लेकिन आप कोई भी नेम रख सकते हैं, उसके लिए कोई स्पेसिफिक कीवर्ड असाइन नहीं है.
अब सर जिस तरह ये स्टैक एरिया के आगे स्टैक लिखा हुआ है, तो अब इसमें
टैग बेसिकली ये कीवर्ड है, लेकिन ये एज अ एरिया नेम आया हुआ है, यहाँ पर टाइटल के तौर पे आया हुआ है, और इसका कोई मीनिंग नहीं है, बस ये टाइटल है इस एरिया का. लेकिन वैसे स्टैक की नेम है, इसीलिए स्टैक हाईलाइट हो गया, वो ब्लू कलर में लेबल हो गया.
और सर इसके आगे अगर हम एरिया का डायरेक्टिव यूज करें तो हमें ये सारी लिखनी पड़ेंगे, स्टैक नो
नहीं 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 नहीं, मैं आपको दिखाई देता हूँ, एक सेकेंड. सो आपको मैं ग्लोबल एक्सपोर्ट दिखाने लगा था बस आपको, बाकी सारी चीज़ों भी कर ही लेंगे. दिस इज हाउ द एक्सपोर्ट वर्ड इज रिटन. इफ यू वांट टू डिक्लेयर दिस लेबल एज ग्लोबली, as this label will be applicable or accessible in your program throughout it, so you may declare that label as a word export. So if you will write export and after that you will write label, so that label will be declared globally. If an interrupt will come or the processor will get reset or anything happen to the processor, this global label will be accessible at any memory location. So ये global variable export कर दिया आपने as a global variable. If you will use the import, then you are asking the assembler that I am importing this label. So wherever this label is, just ask it to come here. Similarly, you are importing the main function. Wherever the main function is, it will be imported inside this area. And here you are adding a branch to this particular label. So we will discuss it in a little while. So this is how the export and import word works. By exporting a label means you are declaring it a global label, and by importing it means you are importing some global variable inside your area to call it. The next word is thumb. As I have already told you, by writing thumb and on top of your program, you are instructing your assembler that I am going to interpret the instructions which are part of thumb 2 or thumb architecture. And the preserve wait. Preserve wait is once again an assembler directive, and this assembler directive is asking the assembler that I am going to preserve my 8-byte alignment of the stack. So stack will be aligned by 8 bytes. So preserve 8 means you are aligning your stack by 8 bytes. Now what is mean by that aligning? This aligning will be shown once we will do the second example of the assembly code. This is how the area is declared. So area is declared by a keyword area. Then you will mention a section name. This section name can be any name. And then the list of attributes. That list of attribute can have one attribute or it can have more than 7 attributes as well. So the area directive will be started by a keyword area, then a section name will be listed, and then its attribute will be mentioned. So section name is the name assigned by the user to a particular data or code section. Whatever area or section or segment you are going to define, you will name it by any optional section name. For example, if you are using a C compiler, that C compiler always mention the section name as .text. जब भी आप कोई C कोड कंपाइल करते हैं असेंबली में, तो उसकी disassembly फाइल खोल के देखिएगा तो उसमें C code is always given a section name called .text. For example, if you want to define a stack, then you will declare that area as a stack area. These are the few examples. We have defined area, then section name my data. I am going to define some data variables which I am going to use in the program. So this section name has a name my data. It belongs to data memory. So this area belongs to data memory. Whichever instructions I am going to write within this area, those will be saved inside the data memory. And it will have an attribute of read write. Read write means at runtime I can read those variables or I can write those variables as well. So read write is an attribute of this particular area. So I am going to define the data section in which I am going to declare some variable, and those variables are either readable as well as writable. Similarly, this is another example, area, stack. I am going to define my stack. What are those attributes list? This is that attribute list. If you will declare an area as read only, then it means it is indicating that this section must not be written to. Once it has been assembled and it has been given an executable file, then in that executable file while runtime, you cannot update that area. So this area will be saved inside the code memory, and that code will be only readable, but it will not be writable. So write access will be disabled by writing an attribute read only. If you will declare an attribute no initialization, it means you are asking the assembler use this. You are using this attribute indicating that data section is uninitialized. We have declared some data in it, but it is not initialized, or it has been initialized to 0. So not initialized means I am not giving you any initial value. I am just reserving a memory capacity in which I will be using that capacity to store some other variables at runtime. So while defining a stack, you have declared it as attribute as no initialization. So no initializations means you are asking the assembler that I am not initializing this space. I am just reserving it for the future purposes. So a section with this attribute contain only space reservation. It will only contain space, or DCB or DCD or DCDW. These all directives will be discussing in the next chapter. It will be initialized to value 0. So whatever data will be written inside no initialization block, it will be initialized either to 0 or to some random value, and the assembler will be and you are asking the assembler that I am not going to use it as the initialized value. I am just declaring it for the future purposes. If you will declare the area as an attribute read write, it means that particular area will be saved in the data section, and it is readable as well as writable. If I will declare the attribute of any area as data, then it means I am going to use, or I am going to store that area into my data memory. So these are not instructions. These are my data. These are my data variables. So data variables will be stored after writing the word data over here. So if you will write area, any optional name or section name with words data, then data means I am storing next coming instructions into my data memory. It belongs to my data, but it is not instruction. So these will not be instructions. These will be just the values of the data variables. If you will write an attribute code, then code means it will contain the instructions to be executed, and that will be stored inside the code memory, and that will be readable only. So read only is the default for the code. If you will declare it as code, then it is default. It is a default setting that by writing code over here, that segment will be readable only. So अगर आप इसको skip भी कर दें, इससे कोई फर्क नहीं पड़ेगा. The code will always be readable in default. And by word align is a specific word that is used to align your memory location. So by default, sections are aligned to 4-byte boundary. Now what is meant by 4-byte boundary? If we will go to the memory architecture, यहाँ पर था एक memory map. Okay, so this is that memory map. ये जो line आपको नजर आ रही है, this line is basically called a boundary. If I will say that I am aligning my memory as 4-byte, it means the one box inside this memory or one drawer of this whole cupboard will contain only 4 bytes. So starting from this particular cursor location till this boundary, I am storing only 4 bytes within this rectangular box. So each memory location will contain only 4-byte data, and your memory will be aligned by 4 bytes. The first address will start from all zeros. Let's suppose it will contain 4 bytes of memory, and the next address will start from 04 because you have already reserved 4 bytes within a single box. So next address will come out to be 0, all zeros 4. The next possible address will be all zeros 8, and the address will be divisible by 4. So each address will be divisible by 4 if I am aligning my memory as a 4-byte memory. So if I will write a simple word align, then align means by default it will be a 4-byte boundary reserved. And if I will put a number over here, align is equal to 2, align is equal to 4, align is equal to 8, then that number will represent that I am going to align my memory to 2 raised to the power number byte boundary. So if I will write align simple, so align means the memory will be aligned by 4 bytes. Each memory location will contain 4 bytes data, and address will be divisible by 4. But if I will write align is equal to 10, then it's saying that I have aligned memory to 2 raised to the power 10 bytes, which is 1 kilobyte, and each memory segment will contain 1 kilobyte of data, and address will be divisible by 1000. So this is how the align keyword is used in your code section as well as data section. If you want to define very large variables, like their capacity can be 64 bits or 128 bits, then you may align that code segment or that area segment with a word align is equal to that particular number, which is your memory capacity.
Excuse me, sir.
जी.
सर आपने पहले अभी एक कीवर्ड यूज किया था preserve 8, तो वो भी मेमोरी अलाइनमेंट के लिए था?
नहीं, preserve 8 स्टैक मेमोरी अलाइनमेंट के लिए है. कहाँ गया preserve 8? आया था यहाँ पे कभी? तो preserve 8 कीवर्ड सिर्फ स्टैक अलाइनमेंट के लिए है. The stack memory will be preserved by 8 bytes if we will use preserve 8 on top of your program. लेकिन ये जो अलाइन वर्ड है ना, ये अलाइन वर्ड हर एरिया के लिए सेपरेटली डिफाइंड है. आप एक एरिया को सिंगल बाइट अलाइन भी कर सकते हैं, आप एक एरिया को 2 बाइट अलाइन, या एक एरिया को 4 बाइट या 8 बाइट या 64 बाइट अलाइन भी कर सकते हैं. सो इट्स अप टू यू कि जो एरिया आप डिक्लेयर कर रहे हैं, इन दैट पर्टिकुलर एरिया विच टाइप ऑफ वेरिएबल यू आर गोइंग टू डिफाइन. अगर आपने लेट्स सपोज 64 बिट वेरिएबल डिफाइन करना है, तो आप अलाइनमेंट उसकी 64 बिट पे कर दें, ताकि आपका एक मेमोरी लोकेशन 64 बिट वेरिएबल को रिप्रेजेंट कर रही हो. In that way, your address will become divisible by 8. Each address in that particular area will be divisible by 8.
सर अगर हम एरिया को अलाइन नहीं करेंगे तो एरर आ जाएगा?
नहीं, अगर आप अलाइन नहीं करेंगे तो मैं बताया डिफॉल्ट उसका 4 बाइट अलाइंड है पहले से ही. ये कॉर्टेक्स एम के अंदर पहले से ही अवेलेबल है कि 4 बाइट अलाइनमेंट ही होगी. तो अलाइन वर्ड अगर लिखना भूल भी जाएंगे तो भी कोई मसला नहीं होगा, वो आपकी 4 बाइट अलाइनमेंट कर देगा मेमोरी की.
ओके सर.
Okay, next comes the assembly program. Now, if you want to write an assembly program, you are supposed to write three things which are most important things. If you do not include any starter file, if you will not include any library, if you will not include any header file or C file in your program, and you want to execute a single assembly code without any starter file, then you are supposed to declare three things in your code. What are those three things? The first thing is the stack size. The very important and the foremost thing to define in your assembly program is to define the stack size. If you will not declare your stack size, the assembler will never assemble your code because stack is a compulsory thing. So the first thing, if you are executing your code or if you are writing your code without any starter file or without any library, you are supposed to define your stack. So the defining the stack is the most important thing in your assembly program. Although if you have included the starter file already had the definition of your stack. So starter file will contain the definition of stack. There will be no need to define any stack in your any other file because starter file will handle that condition independently. So the first important thing, if you are writing an assembly program without any starter file, is to define the stack. Stack size is important. You will declare the stack of any size. If you will write the word stack and you will write something to define that stack, the assembler will get happy. चाहे उसकी definition incomplete भी हो. But still, you are supposed to define the stack size first. Then the second thing in your assembly program, that is the compulsory thing, is to write the vector table. A vector table is the one, if you will look at the starter file, in the starter file, this is the vector table. This is that vector table. You are exporting the word underscore vectors. It's a keyword with the capital V. So you will declare underscore vector with a capital V and S at the end. This vector table include the starting address of each interrupt handler. So it includes the starting address of each possible interrupt handler, which type of interrupt can arrive at runtime. So this is a complete vector table of Cortex M3. If you will not declare this vector table in your program, the assembler will once again not assemble your code. So in starter file, the vector table is already defined. You have defined an area. This area has a section name called reset. Reset is once again an optional name. You may change that name as well. There is data. It belongs to data memory, and its attribute is read only. So read only attribute stored in data memory. Value is name is reset, and this area has exported a label called underscore vectors. So this label will be accessible throughout your code, throughout your program. And this is the starting address of this vector table, and it contains all possible type of handler which can interrupt your normal execution. So this vector table is a second important thing which you are supposed to define in your program if you are not using the starter file. But if you are using the starter file already contains their definition. So if you are not interested in cheap.
सर ये वेक्टर टेबल अगर इतना ही इम्पोर्टेंट है तो बूट लोडर से माइक्रो कंट्रोल को स्टार्टअप पे क्यों नहीं लोड करता, मतलब बिल्ट इन?
ये बूट लोडर का पार्ट नहीं है. बूट लोडर ने आपको सिर्फ नेसेसरी लाइब्रेरीज देनी है बस. ये आपकी इंटरप्ट सर्विस रूटीन का पार्ट है, तो ये आपकी एनवीआईसी के अंदर इवोक होगा. तो ये डेटा मेमोरी में सेव होगा और इसको यूज करेगा आपका एनवीआईसी. इसका प्रोसेसर के साथ इतना लिंक नहीं ना है, इसलिए इसको बूट लोडर का पार्ट नहीं बनाया जाता. So where were we? We were discussing that you are supposed to define the stack size. You are supposed to define the reset vector table. After defining that, the third important thing that you are supposed to define in your assembly program is your reset handler. Reset handler का word होना जरूरी है. If you will not declare the reset handler in your assembly program, then once again assembler will not assemble that project. It will because reset handler is the most common type of interrupt. While executing your program, the processor may get reset. So if it will be reset and the reset handler will not be defined in your program, the compiler will not be able to return to that location. So that is why the assembler will always ask you to define the reset handler in your code. So writing the reset handler is the third most important part while writing an assembly program. Once again, if you are using the starter file already contains the definition of reset handler, and this is that definition. So the starter file already contains the definition of stack, which is, if I will search for the stack memory, this is how the startup, it has already declared the vector table for you, and it has declared the reset handler as well. So the three most important part in your assembly program has been done by the starter file. So if you will include the starter file in your assembly program, then you will not be you are not supposed to define these three things. The starter file will handle all these three things. So needs to perform the following sequence of activities to ensure that user program application is executed properly. That is, the defined stack is available, the reset vector table is available, and reset handler is initialized and defined. So the starter file will define these three things. But if you are interested to write your code without any starter file, then you are supposed to write these three things that I have done over here as well. In my this project, I have included only this particular file, ch.s. So this ch.s contain all three things. What are those three things? The first thing is the stack definition. This is the stack definition. My stack mem is a variable. I have declared it by a keyword space. And after declaring it, I am specifying its capacity, and its capacity is 256 bytes. So I am declaring a stack of 256 bytes initialized to 0, and its name is my stack mem. After that, I am defining another area. This area has an optional name reset. It's a read-only type of area, and I am exporting the double underscore vectors. I am declaring this label. Label will be declared at the extreme left side always. And in this particular table, I am going to declare my stack pointer. I am going to declare my reset handler. Although vector table contain all possible type of interrupts, but these two interrupts are most important. So that is why in the vector table, I have only declared the stack pointer and the reset handler. All other exceptions or all other interrupt handler have been removed. So I am done with the definition of stack. I am done with the definition of vector table. Now the third thing is to define the reset handler. So once again, I have declared an area. In this area, I am going to write my code. So its name is section name is my code. It will be stored in the code memory. It will be read only. So code memory will be the destination. Attribute will be read only. This is the entry point of my area. I am going to export the reset handler. So export means I am declaring this label global. Reset handler, once again, a keyword with the same syntax. R will be capital, H will be capital, there will be underscore between them. Reset handler is once again a label. It will be declared at the most extreme left side. This is my code. So my code is already written in the reset handler. I am doing nothing in reset handler. I am just executing my code. So this is my code which I am going to execute. So this is how you may define or you may run any program, any assembly program without using your starter file. But if you will include your starter file, there will be no need to define the stack. There will be no need to define the vector table, stack, reset handler, everything will be defined earlier. हर चीज पड़ी होगी पहले.
Excuse me, sir.
जी.
सर ये रीसेट हैंडलर में हम रीसेट हैंडलर क्या चीज़ है और इसमें हम कोड क्यों लिख रहे हैं अपना, लाइक हम जो अपना मेन कोड है वो रीसेट हैंडलर में क्यों लिख रहे हैं?
Technically speaking, reset handler is the one which will be evoked whenever the processor will get reset, and it should contain the possible instructions which are supposed to be executed whenever the processor will get reset. ये technical words में बात है कि अगर आप कोई embedded program लिख रहे हैं, then in your embedded program, the reset handler is a label which will be evoked whenever the processor will get reset. Power failure आ गया, processor बंद हो गया, कुछ भी हो गया. Then if the processor will get evoked after the reset handler will be called. And reset handler should contain the basic instructions which are needed to be executed whenever the processor will get reset. लेकिन फिलहाल हम कुछ करना नहीं चाह रहे. हम कह रहे हैं कि प्रोसेसर जब भी रीसेट हो हमारा कोड शुरू हो जाए. तो we are just executing our code. ये basically cheat है. हम assembler को cheat कर रहे हैं कि we are declaring the reset handler. Assembler इस time पर बिल्कुल खुश हो गया कि reset handler available है, whenever the processor will get reset I will call it. लेकिन उसके अंदर हमने cheat code लिखा हुआ है. This cheat code is our own code which we are supposed to execute in your main function, but हम उसको reset handler में लिख देते हैं. So it's
Okay,
just a
sir.
cheating.
समझ आ गया।
ठीक है, वैसे अगर कोई स्टैंडर्ड एम्बेडेड कोड देखेंगे आप, तो स्टैंडर्ड एम्बेडेड कोड में रीसेट हैंडलर में वो इंस्ट्रक्शंस होंगी जो हर रीसेट के बाद एग्जीक्यूट होना जरूरी है। Okay, so while writing an assembly program, stack size, reset handler, and the vector table, these are the three most important things that you are supposed to define. Now comes the reset sequence. This reset sequence will also discuss in chapter 2 as well. Whenever the processor will get reset, it will go to this memory location. This memory location is 0x all zeros. And this memory location will hold the stack pointer value. So it will contain the stack pointer value. For example, if you will look at this particular ये diagram नजर आ रही है सबको? थोड़ी सी blur है. So whenever the processor will get reset, it will go to this memory location, 0x all zeros. At this memory location, the value of stack pointer will be stored. So this is the value of stack pointer. So the processor or the sequence holder or program counter will go to this particular address. It will fetch this value, and this value will be stored inside your stack pointer. So if this value will be stored in the stack pointer will start pointing to this memory location, and this memory location is the starting value of the stack. So the starting value of the stack will be stored inside the memory location all zeros. So whenever the processor will get reset, it will instantly go to this address. After going to that address, it will fetch the data from there, and it will load that data into stack pointer. So the stack pointer will get initialized to this data location. So it will start pointing to this memory location, and this memory location is basically the starting address of the stack. After executing that step, it will go to this address. Now what is this address? This address is all zeros 4. After going to that address contains the value of the program counter, which is pointing at that instruction where the processor get reset. So it will, after going to this memory address, it will go to 0x all zeros 4, and at that memory location, the data which will be stored at that memory location will be given to program counter. So program counter will get initialized to this particular data content, and program counter will start executing that particular instruction. So all zeros will contain the value of stack pointer. All zeros 4 will contain the value of program counter, and after that your vector table will be evoked, reset handler will be called, and reset handler will perform the reset handler operation, and then it will go to the main function. So this is how the reset sequence is executed in your ARM architecture. The one thing which is need to be noted is only MSP is initialized. When we go to this address will contain only one value, and this value is for the MSP. So only MSP will get initialized when the processor will get reset. The PSP will get flushed away. So only MSP will be initialized whenever the reset sequence will arrive, and the PSP will get undefined, or it will be flushed away on reset. Next thing, important thing is the bit field. The bit field T is the execution program status register is set to 1 to mark the thumb state. This is the second step which is not mentioned in this particular diagram. The next step is to declare the T field. What was the program status register? If you go back to chapter 2 again, this was a program status register. And as you can see in the execution program status register, there is a bit called T. This bit will turn high or will be equal to 1 if you are supposed to perform your thumb mode instruction. So if you are in thumb state, then the T bit field will be set to 1 inside the EPSR. So the T bit field of EPSR will set to 1 if you are going to execute your thumb mode instructions. And the link register will be reset to all Fs. So link register will be reset to all Fs. Stack pointer will be reset to will be given the value which is located at this address. Program counter will be located at this. MSP will be initialized, but PSP will be flushed away. And the T field, if you are executing the thumb mode instructions, then T bit field of EPSR will set to 1. This is how the reset sequence occurs. So in reset sequence, whenever a processor will get reset, it will instantly go to this address. It will load the content of this address and store it in the stack pointer. It will then go to this address. It will fetch the data from there and will load into program counter. And the link register will be initialized to all Fs. And the bit field T of EPSR will set to 1 if you are executing the thumb mode instructions. If you are in ARM mode, then this bit field will be equal to 0. Is this point clear? So this is the pictorial representation as well. At all zeros location, the data content will be stored in stack pointer. So stack will start pointing to this location. At this memory location, the content will be stored in the program counter, and program counter will start executing this system initialization code. And the link register will be initialized to all Fs. Now this is how the whole assembly code looks like. As you have seen, we have declared thumb. Thumb is the mode of operation. We are in thumb mode. We have declared the area in which we are defining the stack. We have declared an area in which we are defining the underscore vector or simple vector table. And we have declared an area in which we are going to define the reset handler. So if you are not using any startup file, you have to define these 3 things. And after defining these 3 things, you can write any assembly program over here. So this code is same as that of this code. जी.
सर ये जो एंट्री वर्ड है ये प्रोग्राम की एंट्री है, ये किसी स्पेसिफिक एरिया की एंट्री है?
ये इस एरिया की एंट्री है. आपके कोड मेमोरी में जो कोड मेमोरी जहां से सॉरी आपका कोड जहां से शुरू हो रहा है ना, ये कोड वाले एरिया की एंट्री है.
अगर मल्टीपल कोड एरियाज हैं तो हर एक की सेपरेट एंट्री होगी, वो बताना
हर की
पड़ेगा?
जी हर किसी की अपनी अपनी एंट्री होगी. जी हर सबका अपना अपना एंट्री पॉइंट होगा.
ठीक है.
Excuse me, sir.
Okay, if done with the जी पूछिए. क्वेश्चन किसका क्वेश्चन है?
सर हमने जो अपना कोड लिखा हुआ है वो लिखा हुआ है रीसेट हैंडलर में, जैसे आपने बताया. तो सर अगर सपोज हमारा माइक्रो प्रोसेसर मतलब वो रीसेट हो ही नहीं रहा, तो फिर हमारा कोड ये वाला चलेगा?
जब भी आप कोड को बर्न करते हैं ना अपने माइक्रो प्रोसेसर में, तो वो पहले स्टेप में रीसेट ही होता है. वो रीसेट होता है, उसकी फ्लैश मेमोरी अपडेट होती है, उसके बाद वो अपने आप को दोबारा से ऑन करता है. तो जब ऑन होगा तो इसका मतलब रीसेट हैंडलर तो एवोक होना ही होना है.
ओके सर, ठीक है.
सर ये अलाइन इक्वल टू 3 और 4 ये हमें कैसे पता चलेगा?
देखिए अगर आप सिंपल अलाइन यूज करेंगे ना, अभी सिंपल अगर अलाइन यूज करेंगे तो आपकी मेमोरी 4 बाइट अलाइन रहेगी, मतलब 32 बिट्स आपकी एक मेमोरी लोकेशन पर सेव हो रहे होंगे. अगर आपने इससे लार्जर कैपेसिटी के वेरिएबल सेव करने हैं तो आप अलाइन की अलाइनमेंट चेंज कर देंगे. अदरवाइज सिंपली अलाइन इज इक्वल टू 2 या अलाइन इज इक्वल टू 3 1 रहने दीजिएगा. Okay, let's do another example. In this particular example, we are going to multiply 2 positive numbers which are stored in your memory by repeated addition. We do not know the multiplication instruction yet, so we will try to multiply them, but by multiplying them, we will do the repeated addition. आपको पता है अगर 5 को 2 से मल्टीप्लाई करना है तो it is same as that of के 5 को 2 बार ऐड कर दें, 5 plus 5 कर दें. If you want to multiply 5 by 3, then it is basically addition of 5 by 3 times. So 5 plus 5 plus 5, that would be 15. So we are going to execute a multiplier using the repeated addition mode. And the variables are stored inside the memory. So first we will fetch those variables. After fetching those variables, we will execute the repeated addition algorithm. and the result will be stored in the memory again. So if I will update this file a little bit, at existing file and
Excuse
जी क्या क्वेश्चन है किसी का?
सर हम खुद की सब रूटीन्स बना सकते हैं?
बना सकते हैं बिल्कुल. आपका नेक्स्ट इस वीक के तो आपने सब रूटीन्स ही बनानी है अपनी. और जब आप अपने FYP पे काम कर रहे होंगे तो मे बी आप हर चीज़ की सब रूटीन बनाएंगे. Anyway, this is that code which I was discussing. This is basically an assembly language program without any startup file, and it is multiplying two numbers with the help of repeated addition. If you have understood the lecture, you will be able to decode these instructions as well. In the very first instruction, thumb. Thumb means I am declaring that I am going to write instruction in thumb mode. This is an equalizer variable. In this area, I am going to define my stack. So, in this area, I'm going to define my stack. The stack has been declared and its capacity is 256 bytes. In this particular area, I am going to define my vector table. Once again, in the vector table, I have just initialized the stack pointer and I have just declared the reset handler. All other interrupts has been removed. Now, this is the next important thing. In this area, I am going to define my variables. So I have named this section name as ROM data, or you may give it any optional name. It belongs to the data memory. I am storing those variables in the data memory, and it is read only. So these variables will be read by the processor, but it cannot be written. So it's a read only ROM data variables. The first variable or the first label is called X. X is the name of that variable. It is declared by the keyword DCD. DCD means I am going to declare it as a 32-bit variable. So X is a 32-bit variable and its value is 10. So this is how the variable is declared. X is a label. So label will be at extreme left side. It will have the memory capacity of 32-bit because I have declared it as a DCD. And its initial value is 3. Since it is readable, so its value will remain, its initial value is 10. So its value will remain 10. Similarly, I am defining another variable called Y. Y is a label or name of that variable. Its memory capacity is 32-bit again because it's a DCD type variable. And its initial value is given 3. In the next line, I am declaring another area. Now in this area, I have changed its name to RAM data. The previous one was a ROM data, but it's just a section name, optional name. You may give it any possible name, data 1, data 2, or everything, anything like that. It also belongs to data memory, but its attribute is different. What is this attribute? Its attribute is read write. You can read that variable, you can write that variable as well. And in this particular variable, I am going to store my result. So its name is product. Product will contain the result. Its capacity is 32-bit and its initial value is 0. So I have declared the same area once again, but I have changed its attribute. In the previous area, the attributes were read only. So I can only read that variable, but I cannot update it. But in this particular area, I am defining my variable once again, but its attribute is read write. Read write means I can read that variable, I can update that variable as well. Now in the next area, this is my code area. So in the next area, I have given it any section name .text. This is my section name, or you may give it any other name. It will be located in the code memory. Its attribute will be read only, and it will be aligned by 4 bytes. Your 2 raised to the power 2 is 4, so it will be aligned by 4 bytes. So in this particular area, I am going to define my instructions. I am going to give my code, and that attribute of the area will be read only, and it will be aligned to 4 bytes. This is my entry point, my code memory. In this particular area, I am exporting the reset handler, declaring it as a global label, and within that reset handler, I am going to define my code. Now, what is that code? Let me just build it first. कोई error नहीं आया. So after building it, just अच्छा इसका एग्जीक्यूशन प्लान क्या होगा? एग्जीक्यूशन प्लान कोई बता सकता है इसका सूडो कोड की टर्म्स में? मैंने रिपीटेड एडिशन करनी है और रिपीटेड एडिशन के टाइम पर मैं दो वेरिएबल्स को मल्टीप्लाई करना चाह रहा हूँ. आप में से कोई एक्सपर्ट प्रोग्रामर जो इसका सूडो कोड बता सके?
सर एक पॉइंट पूछना था कि सर हमने एक्स और वाई के लिए मूव नहीं यूज किया.
क्या नहीं यूज किया मैंने? एक्स और वाई के लिए मैंने क्या यूज नहीं किया? आपकी आवाज थोड़ी सी ना ब्रेक हो गई है. चैट बॉक्स में बता दे, मैं बता देता हूँ. चैट बॉक्स में सेंड कर दीजिएगा, मैं बता दूंगा आंसर. चलें, बात हो रही थी सूडो कोड की. इन टर्म्स ऑफ सूडो कोड जी
सर, ये रोम डाटा और रैम डाटा ये क्या कर रहे हैं? ये वाले एरियाज क्या कर रहे हैं?
रोम डाटा रैम डाटा तो मैंने बस ऑप्शनल नेम रखे हैं. ये नेम आप चेंज भी कर सकते हैं, इसका कोई फिजिकल मीनिंग नहीं है, लेकिन बहरहाल उनके जो एट्रीब्यूट्स हैं वो डिफरेंट हैं. अगर आप यहाँ देखें तो रोम डाटा में आई हैव डिक्लेयर्ड दोस दैट एरिया एज रीड ओनली एरिया. सो इसमें जितने वेरिएबल्स लोकेट हुए होंगे वो सब वेरिएबल्स सिर्फ रीडेबल होंगे, राइटेबल नहीं होंगे. और जो आपका सेकंड एरिया है जिसको रैम डाटा कहा हुआ है, उसका एट्रीब्यूट है रीड राइट. रीड राइट मींस दीज वेरिएबल्स कैन बी आर रीडेबल एज वेल एज राइटेबल. सो इसको मैं रीड भी कर सकता हूँ, इसकी वैल्यू को मैं अपडेट भी कर सकता हूँ.
ओके सर, एक और चीज़, जो हमारे वेरिएबल्स हैं वो हम रीसेट हैंडलर में नहीं डिफाइन कर सकते, हमें उसे एरिया में डिफाइन करना पड़ेगा हमेशा.
उसको डेटा में डिफाइन करना पड़ेगा. जो आपके वेरिएबल्स हैं वो सेव होते हैं डेटा मेमोरी में, जो आपका कोड है वो सेव होता है कोड मेमोरी में. सो द कोड विल बी रिटन इन द कोड एरिया एंड द वेरिएबल्स विल बी डिफाइंड इन द डेटा मेमोरी. सो दोनों को डिफरेंट एरियाज में रखना पड़ेगा. एक और तरीका भी है, कोड मेमोरी के अंदर भी आप वेरिएबल डिक्लेयर कर देते हैं, लेकिन उसका मेथड मैं आपको बताऊंगा नेक्स्ट लैब के अंदर. वो एक मेथड है जिससे लोकल वेरिएबल डिक्लेयर हो जाते हैं. तो लोकली आप कोड मेमोरी में भी वेरिएबल डिक्लेयर कर सकते हैं, बट उसका मेथड बाद में बताया जाएगा. फॉर द टाइम बीइंग
सर
जी
सर एक बात पूछनी थी सर. जैसे कि आपने वेक्टर टेबल में डीसीडी रीसेट हैंडलर को डिफाइन किया, वो 32 बिट्स पे उसका हो गया मेमोरी. तो
दोबारा
सर
क्वेश्चन.
आपने जो है रीसेट वो वेक्टर टेबल में डीसीडी रीसेट हैंडलर लिखा हुआ है, इसका ये मतलब है कि रीसेट हैंडलर पे 32 बिट्स असाइन हो गए हैं, है ना?
नहीं, इसका मतलब ये नहीं है. इसका मतलब ये है कि रीसेट हैंडलर का जो भी एड्रेस है ना, वो एड्रेस एज अ 32 बिट वेरिएबल वेक्टर टेबल में सेव हो गया. सो वेक्टर टेबल नाउ कंटेन द एड्रेस ऑफ रीसेट हैंडलर. रीसेट हैंडलर एक लेबल है ना, तो लेबल का एक एड्रेस होगा. So that address has been stored inside the vector table.
सर तो फिर हम ये जो अलाइन टू करें, ये हम किसको मतलब मेमोरी असाइन कर रहे होते हैं? 4 बाइट्स की जो मेमोरी है.
Align से हम memory assign नहीं करते. Align is a different concept. Align is a concept that the memory contents will be stored as a 32-bit aligned chunks. जो एक मेमोरी लोकेशन होगी ना, उस मेमोरी लोकेशन की टोटल कैपेसिटी 32 बिट्स होगी या 4 बाइट्स होगी. ये मतलब है अलाइन का.
तो सर
Okay, I was
किस
asking about the pseudo code of this particular. क्या पूछ रही हैं आप? अलाइन से किस मेमोरी की अलाइनमेंट होगी?
यस सर.
ये कोड मेमोरी की अलाइनमेंट होगी ना, बिकॉज आपने कोड में डेटा सेव, ये अपना कोड सेव किया, तो कोड मेमोरी विल बी अलाइन्ड बाय 4 बाइट्स.
सही, थैंक यू सर.
Excuse me, sir. Sir, आपके लैपटॉप की बैटरी है.
We are left with just 10 minutes. नहीं, चार्जिंग पे लगा दिया यार. वैसे थैंक यू फॉर पॉइंटिंग आउट, मुझे भी यही लगा था. Okay, so I was asking about the pseudo code. We are left with just 10 minutes. The pseudocode will be such that we will fetch two variables. After fetching two variables, we will add x by x and we will decrement y. Yani let's suppose if you want to multiply 5 by 3. So if one variable is 5, the other variable is 3. We will add 5 by 5. 5 will be incremented by 5 again, and 3 will get decremented. Okay, एक बार addition हो गई है. Then we will keep on repeating the same thing again and again till y will become equal to 0. So that is how you will keep on continuously adding 5 by 5, and then you will get the result. So this is that particular loop. I am adding R3, बल्कि ये मैं अभी डिबगर में दिखाई देता हूँ आपको क्या करना है कोड समझ के. So here we are. Reset handler, the start of the reset handler. In the very first instruction, I'm using LDR. LDR is load into register. R0 is my destination register. I am asking the assembler to give me the address of X in R0. So R0 will now load the address of X. After successfully executing it, R0 में कुछ आ गया. This is that value. This value should be the address of variable X. So let's verify it. There is a window called memory window. आपकी यही debugger session के अंदर एक window होगी which is called a memory window. In this memory window, I can write that address. So what is that address? That address is 0x12345602C. So if I will enter it, it will go to that memory location, and here is X located. ये X है. X की value 10 थी ना, तो in hexadecimal it is 0A. So this is X. So the address of X is pointing to by R0. So now R0 is pointing at X. Now let's execute the next instruction. In the next instruction, I am asking the assembler to please give me the address of Y inside the register R1. So now R1 will contain the address of Y. So if I will successfully execute it, after the execution,
सर आपकी आवाज नहीं आ रही सर.
that hello. हेलो स्टूडेंट्स, आपको आवाज आ रही है मेरी?
यस सर, आ रही है आवाज.
यस सर.
सॉरी, मैं इंटरनेट की वजह से लीव कर गया था. एनीवेज, आई वाज आस्किंग अबाउट गेम.
एक्सक्यूज मी सर.
जी
सर, ये जो मेमोरी मैप होता है ये लिटिल एंडियन में है या बिग एंडियन में है?
हाँ, अच्छा क्वेश्चन है. आप खुद गेस करें, ये लिटिल एंडियन होगा, बिग एंडियन होगा. दिस इज माय एलएसपी लोकेशन. This is the lower address. Lower address 30, address 31, address 32, address 33. So this is my lower address. Lower address is stored, LSP is stored at the lower address. So what type of endian is it? If we look at the memory, in the memory, this address at which my cursor is currently, this address is 30. This address is 31, this address is 32, this address is 33, and so on. So if the lower address is holding the LSB, then what type of endian will it be?
Little endian.
Obviously, it's a little endian. In little endian, LSB will be stored at the lower address, MSB will be stored at the upper address. MSP will be stored in the lower address in big endian, while LSP will be stored in the lower address in little endian. So it's a little endian architecture. Now the next instruction is LDR R2. R2 is my destination register, and I am asking the compiler to give me the address of product. So the address of product will be fetched inside R2. So now R2 will contain this value. So if I will go to this particular address, which is 282, this is that address, and at this address product is saved. Product is initialized to 0, so यहाँ 0 ही पड़ा हुआ है. And now the next line. In the next line, I am asking the assembler, please go to this address R0. R0 is pointing to X, remember? So please go to this particular address at which X was located and give me the value of X. So the value of X will be loaded in R3. So if I will execute it, after executing it, my R3 will get initialized to A. And why is that so? Because I went to the address pointing to by R0, which is all zeros to C. I went to that address, I fetched this value. This red highlighted option is the memory contents which are fetched by the processor. So these 32 bits will be fetched, have been fetched by the processor, and now it has been loaded inside R3. So now R3 contains a value of X. So while executing this instruction, I asked the compiler or assembler to please go to this address, which is pointing to by R0. After going to that address, fetch the data has been fetched, and stored the result in R3. So R3 now contains a value of X. In the similar way, if I will execute the next possible instruction, in the next instruction, I am asking the assembler to please go to the address R1 and give me the value from that memory location. So after executing it, we went to the memory location at which R1 was pointing at. So R1 was pointing at 30. So we went to 30. We fetched these 32 bits. And after fetching those 32 bits, we stored the result in R4. So now R4 contains a value Y. In the next line, we are fetching the value of product. So product was initialized to 0, so 0 aa gaya R5 mein. It doesn't change anything. Now the loop. CPC means compare with 0. Compare with 0, R4. R4 will be compared with 0. And what is R4? R4 is my Y. So R4 is basically the Y. If Y will become equal to 0, I will end the loop. So loop will be ended. R5 is the destination address, which is the product location. Product was saved in R5. So R5 will be added by R3. So R5 will be added by R3. This red is showing that this CBC condition was false, so it was not executed. So it will not be executed because R4 is not equal to 0. R4 is 3. I will add R3 by R5. R3 was A. R5 will be stored by A. I will subtract it once. So first increment is completed. I have computed 10 multiplied by 1. So 10 has been added with 0. I will go to loop begin again. So loop begin again. Once again came back to this instruction. Once again checked R4 by 0. So if I will check R4 by 0 again, its condition is false. It will not be executed as pointing to by red. R3 will be added in R5 again. So R3 has been added in R5 again. So 10 plus 10, that would be 20. In 20, our hexadecimal wo 20 14 ho jata. So in hexadecimal, you can say it's 14. I will once again subtract R4 by 1 and will go back again. Once again, the iteration will be performed. The result will be added. Now 20 plus 10, that would be 30. So 30 को hexadecimal में 1e लिखा जाता है. So this 1e is basically representing 30 in decimal. I will decrement y. Now I am done with 3 additions. पहली बार addition की 10 आया. Next time addition की 20 आ गया. Third time addition की 30 आ गया. I am done with the addition. And now R4 is again 0. मैंने y को 3 बार decrement करके R4 को 0 कर दिया. Now R4 is 0. I am done with the addition. I have the result stored in R5. So if I will check this condition again, this will be executed successfully and I will go to loop end. So loop has been broken because R4 was 0. 0 was compared by 0. Condition was true. Label was called and the loop was terminated. And now the last step. The last step is to store the value back in product because we only had the address and the local copy of product. Now we want to update that in the memory as well. So to update the variable in the memory, we are going to use the store keyword. This store keyword will take the data from R5 and will store that data to the memory location which was pointing to app by R2. So R2 was previously pointing towards product. So R2 had the address of product. The store instruction will go to that address and will update the value over there. So if I will go to that address, which is 2 all zeros. So let's go to that address 2 1 2 3 4 5
सर हमारा लेक्चर शुरू हो गया नेक्स्ट
एक लाइन रह गई है यार. So just give me 1 minute. So if I will execute it, after successfully executing it, I can see my value has been updated in the memory. So the product has been updated in the memory, the code has ended, and the result is stored in the memory location. So this is how the program was executed by continuous addition, and I have computed the product of two numbers. Is it clear? And there are a few questions from why didn't we use move instruction? Move instruction only copy the immediate value in the register. It will not copy the address or the data content of a variable. So the variable was stored inside the data location or inside the memory. Then that is why we didn't use the move instruction. We have to store addresses, not values. In what sense you are asking we have to store addresses? First, we have to store addresses. Then we are supposed to fetch the data from those addresses. So we are supposed to do both the things. First, we will fetch the address of the variable. Then we will fetch the value of that.
Excuse me, sir.
जी.